In August 2024, the world's first biometric smart pistol started shipping to customers. Fingerprint scanner, facial recognition, electronic fire control. It looked like the future had finally arrived. Within months, the complaints started. Users reported failures in cold weather. Gloves rendered the fingerprint scanner useless. Facial recognition failed in low light. Battery anxiety became real. What if it dies during a home invasion? The $1,499 Biofire Smart Gun promised to revolutionize firearms. Instead, it revealed something terrifying. The future of pistols isn't about adding technology. It's about removing the human entirely. And that's where this gets complicated, because every attempt to build the combat pistol of 2035 has failed for the exact same reason. A reason that military engineers are only now beginning to understand. By the end of this video, you'll understand why every futuristic pistol idea collapses at the exact same point. So what will a combat pistol actually look like in 2035? The answer isn't what anyone expected. Let's start with what seemed like the obvious answer: smart guns. The logic was simple. Modern soldiers carry smartphones, night vision with AI targeting, drones controlled by tablets. Why not pistols that recognize their users? Biofire's technology looked perfect on paper. Integrated fingerprint and 3D infrared facial recognition systems that independently verify identity. Whichever recognizes the user first unlocks the firearm. The shooting experience was supposed to be seamless. Authorized users simply pick the gun up and fire. Engineers who developed the system came from backgrounds in military ballistics and high-precision weapon targeting systems. They prioritized reliability and speed. Ian McCollum, the firearm technical expert behind Forgotten Weapons, tested it himself and said the Biofire Smart Gun shoots like a gun. There's no delay. For a moment, it seemed like the problem was solved. Military planners started imagining scenarios. Soldiers whose weapons automatically lock if captured. Pilots whose sidearms can't be used against them if they're shot down behind enemy lines. Law enforcement whose guns can't be taken and turned against them. Then reality hit. The biometric technology won't work if users' faces and hands are completely covered. That's a problem when soldiers wear gloves, balaclavas, and face protection in combat. The system fails in extreme cold because fingerprint sensors rely on detecting moisture and electrical conductivity in skin, both diminished in freezing conditions. Facial recognition struggles in smoke, darkness, and when faces are partially obscured by gear. But there was a bigger problem, one that nobody anticipated until field testing began. The Biofire Smart Gun relies on a rechargeable lithium-ion battery. The company claims it lasts several months with average use and can fire continuously for several hours. But combat isn't average use. According to military analysts studying the Biofire system, the complexity of the smart gun is equal to a small satellite. That level of electronics requires constant power, and in combat, power is the most unreliable resource. Soldiers can't charge batteries on patrol. Forward operating bases run on generators that fail. Winter operations drain batteries in hours, not months. The U.S. Army's experience with electronic systems in Afghanistan and Iraq proved this repeatedly. Batteries die at the worst possible moments. This created a paradox. To make pistols smarter, you need electronics. Electronics need power. Power systems add weight, failure points, and logistics burdens. The more technology you add to solve reliability problems, the more reliability problems you create. That's when military engineers realized they'd been asking the wrong question. They weren't trying to build a smarter pistol. They were trying to build a pistol that didn't need a human to make it work. But if biometrics weren't the answer, what was? For a while, the answer seemed to be materials science, not electronics. DARPA researchers started experimenting with advanced polymers and metal alloys. If you can't make the pistol smarter, make it tougher, lighter, and more reliable. The U.S. Army's Modular Handgun System program, which selected the Sig Sauer M17 in 2017, emphasized modular construction and reduced weight. The M17 weighs just 29.6 ounces loaded compared to the M9's 34.6 ounces, a 15% reduction. Modern polymer frames, ceramic coatings on barrels to resist heat and corrosion. Advanced metallurgy creating slides that withstand 50,000 rounds without failure. These weren't incremental improvements. They were revolutionary. Some experimental pistols incorporated graphene-enhanced composites in grips and frames, reducing weight by another 20% while increasing strength. Others used titanium alloys previously reserved for aerospace applications. The goal was a pistol that could survive being dropped from aircraft, submerged in water, buried in sand, frozen solid, and still fire reliably. And it worked, sort of, because while the materials got better, the fundamental design didn't change. Pistols in 2024 still operate on the same principles as pistols from 1911. A slide, a barrel, a firing pin, a trigger mechanism. You can make them lighter and stronger, but they're still mechanical systems with moving parts. And mechanical systems fail. Every smart pistol failed for the same reason, and it has nothing to do with software. So if better materials weren't enough, and smart technology created more problems than it solved, what's left? This is where the answer gets uncomfortable, because military planners started asking a different question entirely. Do soldiers even need pistols in 2035? According to the U.S. Army's Force Design 2030 documents, every Marine will get a sidearm pistol, but that's not about pistols being important. It's about logistics. Pistols are backup weapons, last-ditch self-defense when primary weapons fail. But in modern warfare, when do primary weapons actually fail? Body armor has improved to the point where pistol rounds are mostly ineffective anyway. Most military pistols fire 9mm ammunition that won't penetrate modern ballistic plates. Soldiers carrying rifles, squad automatic weapons, and access to drone support don't need a backup weapon that can't do the job. The U.S. Marine Corps shifted from pistols to carbines for vehicle crews and support personnel because carbines are simply more effective in every scenario. Short-barreled M4 variants and compact bullpup rifles provide rifled caliber firepower in the same size package as a pistol, without the limitations. This created a realization. The combat pistol of 2035 might not be a pistol at all. It might be a compact rifle, or it might be something else entirely. Something that changes how we think about personal weapons. But that shift required solving a problem that's existed since the invention of gunpowder. For years, military researchers believed the answer was directed energy weapons. Lasers instead of bullets. No ammunition to carry, no recoil, instant hit at the speed of light. DARPA spent billions researching handheld laser weapons. The physics worked in laboratories. High-power laser diodes, compact energy storage, precision optics. All the pieces existed. Then they tried to build a prototype. The power requirements were impossible. A laser powerful enough to be lethal requires kilowatts of energy. Batteries that can deliver kilowatts weigh dozens of pounds. You can't build a handheld weapon that generates that much power without making it too heavy to carry or creating thermal management problems that melt the weapon itself. Some researchers tried electromagnetic weapons, railguns miniaturized for personal use. Same problem. The power required to accelerate a projectile to useful velocities demands energy storage that doesn't exist in portable form. Even next-generation ultracapacitors can't match the energy density of chemical propellant. Gunpowder stores an enormous amount of energy in a small package. A single 9mm cartridge contains enough chemical energy to propel a projectile at 1,200 feet per second. No battery, capacitor, or portable power system can compete with that energy density. This is the barrier that stopped every attempt at revolutionary pistol design for 50 years. And it's the barrier that will still exist in 2035. But if nothing revolutionary works, what does that leave? The answer requires understanding what combat actually demands. So here's what a combat pistol in 2035 will actually be. Not revolutionary. Evolutionary. A pistol that looks remarkably similar to what soldiers carry today, but better in every measurable way. It will have advanced materials, carbon fiber reinforced polymer frames, ceramic coated barrels that last 100,000 rounds, titanium slides that reduce weight without sacrificing strength. It will have smart features, but not biometric locks. Instead, integrated sensors that monitor round count, detect malfunctions, and provide basic diagnostics. Augmented reality integration, not in the gun itself, but in the soldier's helmet display, showing ammunition count, target acquisition assistance, and ballistic calculations in real time. It will use advanced ammunition, caseless rounds, to reduce weight, polymer-cased ammunition to prevent corrosion, smart projectiles with basic guidance for extended effective range, and most critically, it will be part of a system, every pistol networked to the soldier's combat system, sharing data with rifles, drones, and command centers. Not because the pistol is smart, but because the soldier wearing it has access to smart systems. The pistol itself remains mechanical, reliable, and simple, according to military small arms. Researchers who studied future weapon concepts from 2020 to 2040, the conclusion was clear. Revolutionary technologies like caseless ammunition have been tried and rejected. The basic design of service weapons peaked in the 1960s, 1970s. What changes is integration, not invention. The 2035 pistol won't be science fiction. It will be refinement. And there's a simple reason. Why? Here's what every failed smart gun, every abandoned directed energy prototype, every revolutionary weapon concept teaches us. In combat, reliability beats capability. Always. The Biofire Smart Gun fails when batteries die, sensors malfunction, or conditions exceed design parameters. Directed energy weapons can't generate enough power. Biometric systems fail when soldiers wear gloves. Every attempt to make pistols smarter creates new failure modes. But a mechanical pistol, a slide, a barrel, a firing pin, a trigger, works in any condition. Frozen, solid, covered in mud, dropped from helicopters, submerged in water. It works because there are fewer things that can break. This is the lesson military engineers keep learning. The future isn't always more complex. Sometimes the future is taking proven designs and making them slightly better. Lighter materials, tougher coatings, better integration with external systems. Not revolution, evolution. The combat pistol of 2035 will look like a pistol from 2025, just like the M17 looks like the M1911. The fundamentals work, ending combat. That's what matters. Not what's possible in laboratories, what's reliable when your life depends on it. In 2035, a soldier will unholster a pistol that looks boring. Because boring means it works. And when everything else fails, boring keeps you alive.